All right, in this video we are going to solve very quickly three rational equations. So this is a little faster than an introductory video to solving rational equations. But when you solve rational equations, you see a rational equation has variables in the denominator. It could have variables in the numerator as well. And anytime we have denominators in an equation or decimals, we try to get rid of those by multiplying by the least common denominator. So we're going to multiply this entire equation by the least common denominator. That means I have to know what that is. Well, the least common denominator is going to be made up of the factors of the denominators that I have. Now, x is a factor of this denominator. It's the only factor. X plus 4 is a polynomial that cannot be factored. Therefore, it's prime. Just like the x is prime, it cannot be factored. So I have two prime factors, like two prime numbers. So my least common denominator is going to be the product of those two prime factors. And that's what I'm going to multiply my entire equation by. Now this should make my denominators go away. So I'm going to distribute this to every term in my equation. So when I distribute this to the first term, the x's cancel, and I have my numerator, which is 1, times the x plus 4, which does not cancel. Now, when I multiply this by 2, 2 has no denominator. The denominator is 1. So there's nothing to cancel with any of this. So I just have my 2, and then times my x and my x plus 4. Then equals, and I have 3. Now, when I multiply this by 3, the x plus 4's cancel, so I just have an x left. Remember, you are distributing this to every term. So even when a denominator cancels with one term, we are still distributing this product to each term. And so those cancellations don't affect what happens in the other terms. All right, now I need to just multiply this out. So I have x plus 4 plus 2x squared plus 8x equals 3x. This is a quadratic equation. When you get rid of your denominators in a rational equation, you will either have a linear equation or a polynomial equation. Of course, a quadratic is a polynomial. So I'm going to put everything on one side and 0 on the other. Now, first, I'm going to combine my terms. So I have 2x squared plus 9x plus 4 equals 3x. I'm going to subtract my 3x from both sides. So I have 2x squared plus 6x plus 4 equals 0. Now, when you solve quadratics, you factor to solve them. And so I'm going to first factor out my 2. That's the first step in factoring. Take out the greatest common factor, if you have one. And if I take this and I divide both sides by 2, that 2 really just goes away because 0 over 2 is really just 0. All right, so we have x squared plus 3x plus 2 equals 0. I factor this and I get x plus 2, x plus 1 equals 0. And when I set each factor equal to 0, then I get x equals negative 2 and x equals negative 1. Now, in rational equations, you have to check your answers just to make sure that they don't make the denominator equal to 0. So put negative 2 back in, not a problem there. When I put negative 2 here, I get 4 minus 2, which is 2, and that's not a problem. So this is definitely an answer. Negative 1, put it in there, it's not a problem. Negative 1 plus 4 is 3. Still not a problem, so negative 1 is also a valid answer. All right, let's do another equation. Each of these equations has a particular feature that I want to talk about. All right, so here's an equation, negative 3 over a squared plus 3a minus 1 over a plus 3 equals 1. All right, now when we look at this rational equation, here's a polynomial that can be factored. It's a binomial that can be factored. I can take out the greatest common factor, which is a, and have a plus 3. So this denominator looks like this in its factored form. So when I go to get my least common denominator, then my least common denominator has to have an a in it because of this a, and it has to have 1a plus 3 because this denominator has an a plus 3, and this denominator has an a plus 3. I don't need two a plus 3s. That would be too many. I just need 1. No denominator has 2a plus 3, so all I need is 1. So I'm going to multiply this entire equation by a times a plus 3. And when I do this, to the first term, I have my negative 3, and the entire denominator cancels. So that's all I have is my negative 3. Now with this one, I have minus 1. The a plus 3's cancel, but the a does not, so I have an a, equals, and then when I multiply this by the 1, don't forget to multiply by your constants. When I multiply this by 1, nothing cancels, so I just have a times a plus 3. All right, so we have minus 3 minus a equals a squared plus 3a. It's a quadratic again, so I'll move everything to one side, so I'm going to add a to this side. So I get minus 3 equals a squared plus 4a, and then I add 3. So I get 0 equals a squared plus 4a plus 3. All right, so again, I want to factor that. I get a plus 3 times a plus 1 equals 0. This means that a equals negative 3 and a equals negative 1. Now when I go to test these, I notice that negative 3, if a is negative 3, negative 3 plus 3 equals 0. This denominator is going to be 0. So a cannot equal negative 3. It isn't that I did anything wrong mathematically, because I didn't. But one of my answers is not in the domain of my function. But negative 1 does not cause a problem here. Negative 1 plus 3 is 2. That's fine. And negative 1 over here is just going to be negative 2. And that's fine too. It's not 0. So my only answer to this problem is a equals negative 1. All right, let's do one more. This equation is 1 minus 3 over 4 minus x squared equals x over x minus 2. Now, here again, I have a polynomial which can be factored. If I factor this polynomial, I get 2 minus x times 2 plus x. Now, one thing I notice about x minus 2 and 2 minus x, these are not exactly alike because they're additive inverses. If I factor a negative 1 out of this 2 minus x, I get x minus 2. So this is equal to negative 1 times x minus 2. You can multiply it out and see that it's the same thing. Well, what I'm going to do then is factor that negative 1 out, and I'm going to put this negative sign with that negative sign and make it positive. So my new equation becomes 1 plus, these two negative signs cancel out and make a plus, 3 over, and now my factors in the denominator look like this. X minus 2, and I'll go ahead and turn this around, x plus 2, so that it looks like what we would expect, equals x over x minus 2. So basically all I did is factor the negative 1 out to put it here, and that made this denominator more workable with this one. So my least common denominator then has to have one x minus 2 in it for the x minus 2's here, and one x plus 2. There is not an x minus 2 squared anywhere, so I don't have to have 2 of those. All right, multiply the entire equation by x minus 2 times x plus 2. And when I multiply 1 times that, there's nothing to cancel, so I've got x minus 2 times x plus 2. Then, with my 3, everything cancels, so I don't multiply 3 by anything. And then when I multiply x over x minus 2 times this, the x minus 2's cancel, and I just have my x times x plus 2 because it does not cancel. All right, we multiply this out and we get x squared minus 4 plus 3 equals x squared plus 2x. This is x squared minus 1 equals x squared plus 2x. Well, if I subtract the x squareds, they go away. And so I get negative 1 equals 2x, and if I divide both sides by 2, then I get x equals negative 1/2. All right, so let's check that. Negative 1/2 will not make that denominator equal to 0. And negative 1/2 in here will not make this denominator equal to 0. So that is a perfectly acceptable answer.